Hi everyone, let's solve this problem. Distinct subsequences. Given two strings s and t, return the number of distinct subsequences of s which equals t. So they have given us s as a string and t as a string. So we want to find number of distinct subsequences of s such that they are equal to t. If you see here, there are three variations of s, like variations in the sense subsequences which are equal to t. So we have to find the number, distinct number. So let's try to understand this. Let's take our s string and also let's take our t string. So we'll start at r, both of them are equal, right? If s of I is equals to t of j, then we can move both the pointers. So when I'm at r, both are equal, so I'll be moving forward. AA both are equal, and BB both are equal, and B again both are equal. Now B and I are not equal, so in this case I will move I forward and j will still be in the same place. Else I will move forward and j will be in the same place. So in this case it has moved to this position. I are both equal, T are both equal. So whenever we reach the end of t string, that means we kind of found one particular way, right? One distinct subsequence. So we are going to add it. Now again let's restart our computation. R both are equal, A both are equal, B both are equal. Here I can choose to move my I pointer to the next to find a different subsequence, right? So in this case, if both are equal, I will also explore one more path, I plus 1 comma j, right? I'll take combination of both of them. So in this case again B are present, but I'm skipping this particular B and moving here. PB are equal, BB are again equal, I are equal, TT are equal. So we got one more subsequence. Then again I will go back here, both R are equal, A are equal. Now BB are equal, so I'll just move forward with next. Now in this case I'll skip the second B. Initially the previous one I have skipped the first B, now I'm going to skip the second B even though they are equal. So in this case B and B, these B's are matched, I are matched, T and T are matched. And in this case we are going to use the cache. So once we compute the cell value, we are not going to recompute it. So we are going to use the dynamic programming, and we are going to use a DP table for the same. And now in this case there are a couple of things to understand. Let's say I have s as a single character and t as empty character. So how many ways are there to convert s to t, like the number of subsequence, right? So there will be one way, like if you don't take this particular character a, there will be one way. Let's say if I have s as empty string and t as a, in this case what would happen? I will not have any way, right? So let's say for example, if I kind of reach the end of s string, there might not be a valid use case or the answer, but if we kind of reach the end of the string t, we will have a valid answer. So we have to return 1 in that case, and in this case we have to return 0. So these are our base cases. So now let's try to write this code. So first let's have the DP table. So and this length is going to be s.length, and we are going to have a new array of length this, and fill these values initially with -1, and then we are going to use DFS approach. We are going to iterate over all the 2D matrix kind of a thing, and we are going to return the answer from 0, 0. So in this case, as we discussed, if I is equals to, or let's say j is equals to t dot length. In this case we know that we have an answer, so we are going to return 1. If I is equals to reaching the end of the string, we are going to return 0. And if the answer has been already calculated, that means dp of ij is not equal to -1. In this case we are going to return dp of I comma j. And later, once we have got this, if s of I is equals to t of j, in this case we are going to store dp of ij as dfs of I plus 1 comma j plus 1 plus dfs of I plus 1 comma j, whatever we discussed, and dp of ij would be equal to dfs of I plus 1 comma j, and towards the end we are going to return dp of ij. I think okay, let's try to run this. Yes, okay, yeah, this should be, this is a syntax error, so let's run it again. Okay, my bad. Yes, let's submit it. Now let's also understand the time and space complexity of this. The time complexity of this particular solution will be big of m cross n, because we are kind of having a two-dimensional array of m cross n, and for each cell we are computing the value once, and the computation is pretty straightforward, right, because we are kind of caching it, and every cell can be computed at max once. So the time complexity will be big of m cross n, and the space complexity of this solution will be big of m cross n as well, because we are using a dp table of size m cross n. I hope the solution is clear. Thank you.